Cold, so cold. Oh, it's so cold. Wise whale, tell me, wise whale of the Arctic, how do you stave off this cold?
I use blubber.
Almost sounds like you're saying I should just eat lots of chocolate and get super, super, super fat.
That works for whales, but not for humans.
Well, that's not super helpful. It does give me an idea for an experiment, though. I could do a shed science. Take my mind off this blasted cold. Hi there, welcome to another Shed Science. It's been a while. I filmed the first batch of Shed Science videos in lockdown, and then I went back to work and I was super busy. But now we're in another lockdown and I've got just slightly more time on my hands. So I thought I'd bring you another experiment that you can do at home. By the way, if you're wondering why I am animating myself for this video, it's because I can't film in my normal shed. I've been doing quite a lot of home improvement and DIY recently, and therefore my garage/shed looks a bit like this. So the choice that I faced when it came to making this video was either taking the time to clean my shed, which I did not fancy doing, or just animating myself. So I've been thinking about the cold, and I've been thinking about how different animals stave off the cold, in particular how aquatic mammals stave off the cold. We're talking seals, we're talking whales, we're talking walruses and narwhals. So we're going to look at an experiment, actually two experiments, double experiment. And they are experiments that you can do yourselves at home. So by all means, grab some of the equipment that I'm going to show you and have a go yourselves. So for these experiments, you're going to need some lard. Lard is a bit like butter. It's animal fat. It's used for cooking, especially used for frying things or as a sort of butter alternative. It goes very, very well in Welsh cakes. And what makes it useful for this experiment is that it is animal fat, so it will act in the same way that blubber does for walruses and whales and narwhals and seals. So you're going to need some lard, a bowl, and some gloves. And isn't it lucky that so many of us have PPE lying around the house at the moment? Into your bowl, you're going to put some water and some ice cubes. You want this water to be very, very cold, much like the water of the Arctic Circle. You don't need gloves to do this. You're welcome just to smother your hand in lard for this experiment, but that's not very nice. It's awfully greasy and horrible. So I recommend wearing a glove and then filling another glove with lard. You want to squeeze that lard down into the fingers. You want to make sure the inside of that glove is completely covered in lard. So then this is the fun bit, the gross, disgusting part. You get to stick your hand inside this glove. And then once your hand is in, you want to squeeze all this lard around. You don't want big lumps of it. You want it to be covering your hand as much as possible. And you only want to do this to one hand. Your other hand you want to leave free. The nice fun bit of this experiment is then to put both of your hands into the ice cold water. One hand is just a glove. The other hand, I've got 2 layers of gloves and I've got the very important lard. As you can see, after 49 seconds, I had to take out my hand that just had the glove without any lard on it because it was too cold. Obviously, if you're going to do this experiment yourself, don't leave your hand in for so long that you get frostbite and your fingers fall off. Just do it until your hands are too uncomfortable to keep in the water. And at 1 minute 34, my other hand with all the lard on it was finally cold enough. So my lard covered hand lasted about 45 seconds longer than my other hand. That fat on the outside of my hand insulated it. So this experiment shows us that lard and fat in particular is a really good insulator. Now, the reason this is important is because marine animals live in water, very, very cold water, ice cold Arctic water. Mammals are warm-blooded and we need that heat to survive. If we're in something very, very cold, then all that heat gets wicked away from us and we end up losing that body heat very, very quickly. However, a fatter animal is insulated. That heat that's coming out of their bodies gets turned around, gets kept inside the body by those layers of fat. Therefore, the animal is able to keep itself warm. It doesn't make more heat, it just keeps the heat in. Now, when I did this experiment, I wondered if it would work the other way round. Body fat can insulate you and keep you warm, but can it also keep you cold? Initially, I thought that if you heated something up and covered it in lard, actually the lard would help it heat up because we use it to cook things, to fry things. So I decided to do an experiment to test this out. And again, you can do this experiment too. You need some lard, some eggs, some plastic cups, some coffee, although that's just for me, you can't have it, keep your hands off. And you need a pot of boiling water. Into one of the plastic cups, I've just added some cold water and an egg, submerging the egg in the water. And then I'm putting lard into the other cup. So I'm putting lots and lots of lard in there and then an egg. And then I'm going to cover the egg in even more lard. So one egg is completely surrounded by water, one egg is surrounded by lard, and both of them are going into the pot of boiling water. So if you were going to make a soft-boiled egg, you'd leave it between 3 and 5 minutes. I left mine for 5 minutes, and if you were to do this at home, I would recommend 3 or 4 minutes to give you a good result. So into the purple cup, I am adding the egg which was in the water. You can see that it's actually cooked all the way through. All of the white has cooked completely. Most of the yolk has cooked as well. It's fairly solid, but there's no liquid part of the egg left. It's all cooked, so it is a solid. It would be a bit disappointing to eat if you wanted that as an egg, but it is edible because it is cooked. Into the green cup, I'm going to crack my egg, which was in lard. As you can see, it's actually still liquid. Parts of the white have cooked a little bit, but I've still got lots of white which isn't cooked. It's still very liquidy, and the yolk is completely liquid as well. In the pink cup, which was just in water, I've got cooked white and I've got cooked yolk. In the green cup, which was in lard, I've got a little bit of cooking of my white, but nothing of my yolk. This was a bit counterintuitive. I thought that if you used lard to help cook things, then it would help make things hotter. But no, it actually works as a thermal insulator both ways. It has kept the egg colder than if I just used water. It's absorbed all of that heat energy from the boiling water in the pot. So lard as a thermal insulator works both ways. It keeps hot things hot and it keeps cool things cool. Of course, there's a reason that animals that live in really hot climates aren't covered in fat. You don't get really, really fat lions and really fat zebras living in the Serengeti. So there's a little bit of research you can do. Why is it that we particularly want our mammals to be fatter when they are living in cold climates, but not in hot climates? I do hope you have a go at these experiments yourselves. It's quite a lot of fun. You could have different people in your household having a go at how long they can keep their hands in the water with and without lard. So do please consider having a go at these science experiments. In the meantime, please stay safe, be awesome, and thank you very much for watching. Bye-bye.